So let's look at a 3x3 system of differential equations. So suppose this is a coefficient matrix of a system of differential equations, and we want to find the solution x of t. So we are going to subtract minus lambda I from this. Then lambda gets multiplied. The only times we get lambda is on the diagonal, because lambda times 0 is 0, so we just get lambda on the diagonal. So when we subtract, we are going to evaluate, find the lambda that makes this determinant of a minus lambda I equal to 0. So I'm trying to evaluate this a minus lambda I. So I will get 2 minus lambda, negative 5, 0, 0, 2 negative lambda, negative 1, 4, 1 minus lambda. So we want to evaluate this. We want to find the lambda that makes this determinant equal to 0. So that's what we are trying to do. And one way to evaluate this determinant is we could take 2 minus, or I can just write it here, 2 minus lambda, 0, negative 1, negative 5, 2 minus lambda, 4. So we are going to multiply this diagonal, and this diagonal. So anytime there's a 0 on the path, we get a 0 and a 0. So we are only left with the main diagonal. And let's look at the other path too. There's a 0 here, there's a 0 here, there's a 0 here. So we get a 0, 0, 0. So the only thing we get here is 2 minus lambda times 2 minus lambda times 1 minus lambda equal to 0. So then we get lambda is 2. This has a multiplicity of 2, and lambda is equal to 1. So let's substitute let me get rid of these. We are going to look at the case lambda is equal to 1. If I put 1 here, I get 2 minus 1, negative 5, 0, 0, 2 minus 1, 0, negative 1, 4, 1 minus 0. So if I substitute 1 for lambda, for the case lambda is 1, 2 take away 1 is just 1. The same thing here, 2 take away 1 is 1. 1 take away, I don't know, here. 1 take away 1 is 0. So I get 0. And then to find for this eigenvalue lambda equal to 1, I want to find a corresponding eigenvector, AEC, and I set it equal to 0, 0. So I get 1 times A minus 5 times B, 0 times C is equal to 0. I get 0A, 1B is equal to 0, and I get negative 1A, positive 4B is equal to 0. So B is equal to 0. And if b is equal to 0, that also makes a 0. So then the only thing that is free is c. C is the free variable, so c can be anything, or c is equal to 1. And then a and b are always 0. So that's what we get. And that is C1 ET. That is going to be one of the solutions. Now we want to find the other ones, the solution for when lambda is equal to 2. So the case lambda is equal to 2, they get the following matrix. 2 minus 2 is 0, 2 minus 2 is 0, 1 minus 2 is negative 1. And then we have the rest of the numbers, which is negative 5, 0. And we have 0 and 0, negative 1 and 4. We want to multiply it by matrix V that has ABC component and set it equal to 0 to find the corresponding eigenvector for lambda is equal to 2. So 0 times A minus 5 times B, 0 times C, I get minus 5B is equal to 0. So if minus 5B is equal to 0, from the last equation, I have minus A plus 4B minus C is equal to 0. We substitute 0, we get minus A, because this implies B is 0. So when we substitute 0 for B, we get minus A minus C is equal to 0. That means A is equal to negative C. So what kind of vector do we get for this one? One of the possibilities is when B is always going to be 0. But then if I let A, for instance, to be, or C to be negative 1, then A is going to be positive 1. So that's one possibility. So I would say I need one more. I need one more vector. But how do I find that other one vector? I'm just going to, I cannot pick, for instance, this is one vector, but I need two vectors because I have a multiplicity of 2 for lambda is equal to 2. So what is the other vector going to be? For instance, if I pick C to be positive 1, then A is going to be negative 1. But these two are linearly dependent. So there's no way for me to come up with another vector that is not linearly dependent to this vector. So to find the other vector, we have A minus lambda I. This is going to be matrix. If we multiply it by some vector V2, we want to get this vector V1. If this is vector V1, we want to multiply this A minus lambda I by some vector V2 to give us V1. And then that guarantees that V2 is going to be linearly independent. So I have 0, negative 5, 0, 0, 0, 0, negative 1, 4, negative 1. I want to multiply it by vector ABC to find a vector that is going to set equal to 1, 0, negative. So 0 times A, negative 5 times B, 0 times C is equal to 1. So I just get negative 5, B is equal to 1. Or divide by negative 5. That gives me B is minus 1/5, okay? So from the last equation again, I have negative 1a plus 4b minus 1c is equal to negative 1. We're multiplying this by a, 4 by b, negative 1 by c. So that's, then you set it equal to negative 1. That's how you multiply a matrix by a vector. So we know b is negative 1/5, so we get negative a plus 4 times negative 4 times negative 1/5 is negative 4 over 5. So this becomes negative 4 over 5 minus 1c, or just c, equals to negative 1. I'm going to add a 4/5 to both sides. I get negative a, negative c is equal to negative 1, can be written as negative 5 over 5. That's what negative 1 looks like. So we get negative 1/5. If I multiply both sides by a negative, I get a plus c is equal to positive 1/5. So then we know that a is equal to 1/5 minus c, right? So, for instance, if I let c equal to 0, if I pick 0 for c, then a is 1/5. So that's my other vector. So I'm missing one element, sorry about that. So I have b is always minus 1/5. If c is equal to 0, a is positive 1/5. Now, how do I put the answer together? So our answer x of t is equal to c1 we get 0, 0, 1 plus I'm going to write c2 parentheses not yet, c2 e to the power 2t plus c3 e of 2t. So what vectors go here? This one is 1/5, negative 1/5, 0, and this one is just going to be 1, 0, negative 1 here, and 1, 0, negative 1 here. So now I have the following solution, and all three are linearly independent.